So I spent quite a time yesterday learning Docker, and these are all my notes. So it won't be a regular presentation, but I think you will be getting a good idea after this recording. So Docker is all about containers and images. So when someone says it's a Docker image, it means they're talking about a template file, a blueprint, or like a CAD diagram, just like a class file in Java. And Docker container is the output of the image file. So say that if your network OS, if he is onboarding trainee, when the service desk releases the OS to them, it will be releasing an image of the OS, and it will be having all the exe files and the DMG files in it. And once you initiate the process of image copy, it will become a container oriented approach where all the softwares are installed in order in which it's specified in the image. So that's the difference between image and container. Container won't exist without image, and Docker client is the software that we use um, to work with Docker. So it is basically made up of two components. One is Docker client, host, and Docker engine. And Docker engine has another name called Docker daemon. So these are the key terminologies you should be aware while working with Docker. So first, the first reason why we are going for a container-based approach is so this is my case. So where I used to work for Walgreens, used to work for Walgreens, where whenever the business comes up with a new idea of putting a tax, applying tax for products like beer and wine, building a POS-based applications, the first thing they do is they start it by procuring a new server with a pre-installed Linux OS, which is licensed. I don't think it is licensed. Linux server antivirus, which is licensed, and then we always have a discussion whether it should be fast or have a lot of capacity in it. So we mostly end up in buying a big and fast server because we don't want to compromise the business. And while estimating the capacity of the machine, like when we talk about resources, it is CPU time, the the RAM we use, and the storage space we use. So we always estimate it based upon the number of stores available in the country, and putting some percentage to it, and finally we buy the server, and then comes the DevOps team which maintains the server. We need to go for disaster recovery, pay someone to take care of it. So these are the things that happened in the early 2000s, maybe, yeah, 2000s. And what happened was, we, just like human brain, we use only 10 to 20 percentage of the whole application, the whole server we bought, and it has, being Linux, the root, the lib, the etc, every folder is linked to that one application, so we cannot run another application because load balancers were not that popular that day. So 8080 port will be more 80 portal, and you cannot have another application running in a different port. So all these problems were on. You can have multiple softwares in it, but you cannot have multiple applications running. If it is application running, then it should be a sub resource within the same application. So that was the problem. Then the company named VMware came. The VMware came with a technology called hypervisor, where they have a server here, and they have a software which enables this technology called hypervisor, which basically desires to gives the option to the developers or whomever maintains the server to slice the system virtually. So that say that when we develop application, we say that we want this much amount of memory, this much amount of disk space and CPU, and it will be converted into percentage by the whomever is maintaining the system, and it will be, that slice will be given to us, and you have the capability of installing your own OS over that virtual machine, Linux or Windows server, whatever you want, and it comes with a cost unless it is an open source OS, and then you deploy the application app. So say that if it is a 2 TB, 32 GB RAM, and 10 gigahertz computing speed based computers. When you divided that into 4, it becomes basically a slightly enhanced laptop. So the disadvantage here is the application cannot scale, and the maintenance, the antivirus, disaster recovery, the team that maintains it is again a cost to it. But it was okay we were okay with this approach for the last 10 to 15 years, because it was better than buying a physical server and wasting the resources compared to using it in a better way. So that's how VMware was surviving. We were surviving with VMware, and then came the um, container architecture, where we still have the same server, but instead of hypervisor, we go ahead and install the operating system. Mostly it is Linux based, at least with Docker, and over that we place a container, and every container has its own application. Could be any number of applications or same application. So notice the gap here in this area. That is where a system can scale. Say that Unit Hub is running today, and we are requesting for 60 instances. So we have 60 containers in it, and tomorrow we decide that around the time of September or October, when there is traffic is not that much, we can scale down the resources, the containers. So we have good scalability here. So it is not very mature in a it is not a very mature framework yet, because it is still in 1.0 version of the jar, but it's evolving in a great speed. And when you start an application from this container on this OS, on this server, it will be extremely fast. We will be seeing a demo soon. And it is cheap and meaningful way of usage of measures. So hypervisor for VMware, just like that, a container is for Docker. So what about this Docker project? So Docker project, before that, Docker was a different company called .cloud. They wanted to build a PaaS based business, but they had this Docker based project that enabled a lot of the things what they are doing today, like storing an image, creating containers, and they felt the technology, whatever they came up with to do that, was innovative, and they sold the company .cloud and started enhancing the project they did to enhance their .cloud business. And it was then acquired by, so the company became a Docker Inc. So Docker Inc. owns Docker project, just the releases, but it is totally maintained by the Docker community. So anyone can contribute. Like, it is written in the Go language by Google, and it came only 3 to 4 years back and released once in 2 months. The major contributors are IBM, Microsoft, Red Hat. These are the guys who often contribute to it, and they have their own enterprise versions of Docker. So just like in Spring Framework, we have Spring Core that takes care of bean creation and all the basic components creations of Spring, and then we have other libraries over it, like I'm just like Spring JMX or Spring tags library. We have a lot of other Docker library, but Docker engine is the core one. It is otherwise called as Docker daemon. So Docker Hub is, you can compare it to GitHub. So GitHub, we have a lot of code repositories, just like the Docker Hub is a image repository. So you can just see the number, how it is being used nowadays. So what basically this image can hold? Image can hold anything. Image can hold starting from just a software to OS to applications. So I have seen people using Oracle based images. So instead of installing Oracle, setting up your IP port, ID, password, all these things, instead of that, download an image which has Oracle background, and you can just start running it in Mac in very few steps. So this is how Docker Hub. Docker Hub is almost GitHub based GitHub kind of site, you can immediately see that we have repositories, we have resources. So I can search for any, for example, if I want to start working with MongoDB, just go ahead and search for MongoDB, and you'll get a lot of repositories like that. So in a very simple, using a very simple command, we can just start executing it. So see the number of pools here. So this is the command we use. So once you download the image, just run this command and run this on this port, and MongoDB will be up running in 27017, which is the dedicated port for Mongo. So matter of seconds, you keep in, start working with the tools whatever you want. That's how Docker is designed. So this is for a tool. I'm pretty sure that you will be having something for Ubuntu OS itself. Ubuntu OS official. So this official Ubuntu will be having just the name, and if it is not from enterprise, it will be having a username slash their version of Ubuntu. They take the Ubuntu, they pull the Ubuntu, make some changes, and use it. That's how they do it. So that's how Docker Hub. So we still have like just like that, we have a separate GitHub enterprise level GitHub for dedicated for HomeAway. We can have Docker Hub dedicated for HomeAway, and yeah, that's it. That's all about Docker Hub. And this is one interesting topic I learned. So Docker started doing this project, and this company Rocket Apps Specification took the project, open source project, and they completely went in a different direction by pointing out to major standards violation and security issues that Docker had. These two guys really acted mature. They started a kind of a council, a team. They started the initiative, a governance council, where they said we can define the standards and we can have it, and we can still have it as a Docker version of the project, but we will follow your specification, and we will make sure that we are not neutral to any vendor or a platform, and get this going. So they started this initiative, and so Docker still remains Docker. You won't even feel that this company is involved. Preparing for Docker for organizations, like we should accept that containers are coming. So I know HomeAway is way beyond the other companies, but we should make sure that everyone should get ready for a container-based architecture. No more instances scaling up by requesting it to DevOps. Just like you should be able to run commands by yourself. And fourth point is very important: get developers and ops talking to each other. And so it's not only Docker. So Docker is just a starting point. We have a lot of tools that will make Docker a more efficient, a container-based environment company by having the tools like Swarm, Docker Host, and then Tumtum, Mesos. We are using Mesos. Docker is great for both cloud as well as on-prem deployment. We're going to see that. So what can containers do? So we have stateless applications nowadays. Like nobody is worried about session. Nobody uses a lot of caching or storing their last page visited, and also it is all mostly static content, and they're modern. They do everything in the business side and just present the content whatever user wants to know. Stateful applications where we store data. So if you go to a restaurant, and if the waiter remembers you, he will just bring you the food what you usually order. And Docker Hub, the most popular official repos on Docker Hub. So you see the ranking. All the big companies will be here: MySQL, Mongo, Jenkins, CentOS, Nginx, Redis, Node. Everyone have the images hosted in Docker. So you can go ahead, just download the image into your repository, do your changes, and you can have your own version of MongoDB. This is not a very important topic to discuss. So Docker Hub is like App Store to iPhone. Docker Hub is like that for IT companies. So image storage is called registry. That is the term you need to use. So Docker, just like Docker Hub, we have lot of other websites which host these kind of images like Quai.io, and then something with Amazon. Also, we have a site in which they host these kind of images, container-based images. And therefore, the other question that comes was, are they ready for production and enterprise companies? Um, yes. So we go for the commercially supported ones. So they release on every night. They have a version up running. But if you start using that tomorrow morning, or the next day it might not be available because they might not be stable and they be going through some kind of stable bug fixes. And when I talked about the orchestration tools, clustering tools, management tools, um, Swarm was one of them, which was really impressive. It's again cluster management, just like in Hadoop, it has a master, slave, leader, manager. And if you see how it how Docker helps us with its tool when in the cloud and on-prem base deployment. Swarm is for managing the whole Docker clusters. Multiple Docker engines come under one Swarm architecture. An engine is where you run the daemon, you download the image, create container, and that is for building it. For shipping it, use Docker Hub. It means like GitHub. Just once you're ready, put the whole artifact into the Docker Hub. And once Docker Hub has it, you can use TomTom on a cloud to deploy it. And I think we are using Mesos to do that. And then Docker Trusted Registry is where um, it's actually a register where you can use content safe images where cloud is not in place. And so this the below one, we are not very much interested in that because we are taking the top approach. So all these companies are container based companies. They have their own container based implementations and lot of tools that work with containers, like tools to get into container, find out the logs, issues, errors, how to improvise, how to cluster easily. So you see the company called Mesosphere. That's what we use in HomeAway. And of these three missions of container orchestrations, I learned a lot about Docker Swarm and container orchestration companies like Kubernetes, which was a part of Google. They have their own container management system, and Mesosphere data center operating system is what we are using. Core Fleet OS, OpenStack Magnum. These are all companies what we can choose for orchestrating Docker images and containers in case if we want to go with a different one. So basically Docker runs on a Linux machine, but in Mac we have a facility which exposes it back to our terminal itself instead of we opening a VM and doing it. It is achieved by technologies like HyperKit, DataKit, Moby. So all separate topics by itself, and using these three technologies. So when you type it in the command prompt, you can see the version. It is actually running on Linux, but the client is our terminal is Mac, and it gives the version of whatever API and version of Docker we're using 1.2 12.6. So Docker commands like these are useful Docker commands. So let me see, just run very few commands here. So So Docker version and then Docker pull hello world. And this pulls, I already have this image downloaded into my system, so you can see docker docker start hello world. Oh my god, no such container. Okay, docker psa. Okay, we have this, right? Docker start. Okay. Now if I see what is exactly running, let me check the command. Yeah, Docker run hello world should have worked. Latest not found. Anyways, let us start this. So when you start this image, it's up running. Okay, let me give a new name. So I have this image created by this person named Nikhil Poulton, and I'm giving a name to it, and I'm going to run it in a detached mode. The image is configured with the web application that runs on 8080. So I'm requesting the system to run it on 9080, and it's going to be detached mode. So just execute it. So if I go ahead and run the application in there it is. So this is what he has hosted. So if you want to stop it, the command is very simple. You go ahead and stop it like docker stop and if you come ahead and hit the application, it should not work. I think it is still stopping. Okay, I think I didn't stop the correct application. So which is running? Oh, this is running. So stop this application, this container ID. So docker stop this, and I'm 100% sure it will be stopped now. Okay, yeah, it stopped. So just see the time it takes to start and stop the whole application. Just don't think it's a small application. This is applicable for almost every application we are developing. So this gives the container ID, what is the image I used to create this container ID, and what is the location of this file system, when was it created, what is the current status, what port is forwarded to what port, what is the short name I gave. So these are all the useful commands with doc. You can try it with all our unit hub and whatever code we have, just like the Spring Boot containers. Apart from that, yeah, this is how the so for example, if you run the command docker run hello world, if the hello world image is not present in your system, it will call the daemon. Daemon will go ahead and see whether you have an image in a local system. If it is not there, it will go ahead and pull it from the hub basic library, and that's how it works. IT means interactive mode. which means like for Ubuntu, you don't have to run anything. We need to interact with the OS to do things, stuff. These are all the basic commands we use: docker run, docker pull, docker images, docker remove images, ps stop, remove container. So swarm mode, I'm going to talk in a detailed manner in the next video. But for now, these are all the terminology we use. Cluster as a swarm, and manager nodes, we can have up to 3 to 5 managers. Just like a Hadoop system, we have slaves and managers. And services is only available during swarm mode. Services where we can update our version to a new version, and using a concept called parallelism. And then we can scale and reduce the application by giving commands. And we have a wonderful concept called load. I think the name is scale mesh. So even if one of the server is down, even if you try to hit that server, it will be automatically load balanced to another server which has hosting the application using this technology called scale mesh. So we'll talk a lot about swarm mode theory and a separate video, but this is all the basic things you need to know about how Docker is all wired up and working. That's it.